Hello, let us introduce ourselves. My name is Oleg and this is Leonid.
Hello.
We are NFT analysts in Exactpro, and today we are going to share with you a couple of ideas related to latency measurement in various highly performant trading applications.
In our analysis, we would like to focus just several points based on our own experience being a part of LSC group and working on projects from Toronto to Singapore and from trading venues and market data distribution systems to post-trade.
Let's discuss first what we measure. In order to get an impression about latency of the trading application that we test, we measure time from order receipt to order acknowledgement, time from order acknowledgement to public broadcast, and also time from tick receipt to matching engine usage. To get fair values for these metrics, we have to exclude several delays related to an application on the user side. Yes, we have to exclude delays related to transmission to and from external clients or venue, and we also have to exclude clients or venues, latency of clients or venues' own system.
To achieve this, we capture all data just from outside firewalls. This way, we don't exclude the network package transaction inside the application environment. This gives us the ability to customize the environment as a whole so that we can maximize its performance. And also, such testing helps us to evaluate configurable parameters of the network and application working together.
We have tested several production systems where the monitoring tool periodically sends orders to single test instruments, and according to measured response time, provides latency value for the system as a whole. The question is it a system latency we really wanted to measure?
In real life, in the system, there are short periods of time with high user activity as well as periods of time with low users activity. And most of the time, the system is idle, which means that the probability of such test order being sent at time with a low activity is much higher than a time when high users activity is observed. On the other hand, real user orders will be sent exactly at time with high users activity in the system. In this case, for one test order, we will have a latency for particular test order for the test instrument, but not a real latency that customers might observe at time.
To get a proper view on the latency of the trading application that we test, we use composition of two following approaches: model-based approach and metrics-based approach. Let's discuss first model-based approach and how we use it. We analyze data from the real production environment and prepare an injection profile which is as close as possible to the real life of the application in terms of load distribution and load composition. And using this prepared profile, we stress the application in order to estimate its performance limits under stressful real-life daily conditions.
Oh. Okay, and but if we observe any latency problems in the system, we need to drill down to determine the root cause of the issue, and this is where metrics-based approach helps us. So let's discuss a little bit about the metric-based approach. Here we need to develop synthetic loads to determine quality indicators for separate components, message types, and different rate distributions. And so to sum it up, both these approaches, we want to see the system under different types of loads to cover expected and try to cover unexpected situations in the system, and to answer the question: does the system meet the requirements? And at the same time, does it behave consistently under the load?
So in order to calculate proper latency values, we have to analyze a huge amount of data. And we have to be effective while we're processing it. How can we achieve this? Well, obviously matching a whole set of inbound messages against a set of all outbound ones is not an option, since it's time and resource consuming. You can run out of time on hardware resources while you're processing millions and millions of messages using this approach. What we have found to be a more effective way is the usage of so-called sliding window during process of collected data analysis.
Okay, let's see how it works for order-to-order acknowledgement calculation, this example. So a processing tool passes the collected data and places all recognized orders into some kind of a buffer. You can see it. Let's call it open order buffer. Each order in this buffer is assigned with some kind of timeout, which is bound to timelines stored in the data which is being processed. So it might be just, for example, plus 1 second from the time a particular order was received, according to the data we're analyzing. And at the same time, tool tries to match recognized order acknowledgement messages against orders in our buffer. And here we have two options. So first option, if such match happened, the latency of recognized pair is calculated, stored, and the recognized order is removed from the buffer. And the other option is for all unmatched orders. They also will be removed from our buffer, but only when they hit the timeout limit.
Moving further, we'd like to explain how we analyze calculated values. So there is a number of ways to look at your data. You can look at average values, or you can look at maximum ones, or you can even look at percentiles for both of them. But these charts are boring, and you won't be usually able to spot signs of anomalies which affect or could affect your system's performance. This is due to the fact that all these metrics that I just mentioned provide one single number for the thousands of events.
We use latency distribution charts as the first place to look at the data we've got. This is because you have to look at your data closely in order to understand the system. And such charts, latency distribution charts, usually make you ask questions about the picture you see. For example, here's why is there a shoulder here? Or another example, why am I seeing 2 peaks instead of 1?
So to conclude our presentation, we would like to share with you how we prefer to finish our performance tests. So it's a pretty simple idea. We think that performance tests should kill the system. In this way, we verify several points. We check the requirements, we check system limits, and we also challenge ourselves by proving that our understanding of the system and our test tools can go beyond the borderline of the requirements and evaluate the real limits.
Modern technology is developing very rapidly, and only continuous improvement of our tools, our knowledge about the industry, technology, and testing is able to keep us in sync with that, including the relevance of our products and our approaches to the different areas of non-functional testing. Thank you.
Thank you. If you have any questions, we're here to answer them.
My name is Kirill. I'm from Bank St. Petersburg, and I have a few questions. First, how do you synchronize time between server on exchange side and your server or working machine. The second one is do you look up more deeply in the cases when there is a maximum latency periods? What the reason for that? Or you just say that's it and well, it's an application problem?
The time synchronization is not an issue, let's say, for our calculations, since we, as we said earlier, we get all the required data. I mean, inbound messages and outbound messages at the same place. It's a client access firewall. So it's like a border for the entry the system and exit it. Did I answer your question?
Yeah, yes.
Okay.
Yes, thank you.
And for the second question, yes, we look at our data. So if that is why we are using latency distribution chart. So if we see some anomalies in the distribution of the latency, we look at our data to understand what's happening there. So to spot anomalies in the behavior of our application.
So you give your client the reasons what was the reason for this latency and some ways to resolve the problem, right?
Yeah, usually we spot some performance issues in the application under the test by looking at these, let's say, cases.
Okay, thank you.
Gory Barts of Moscow Exchange. Did you analyze the time it takes from point A to the entry of mention engine? Because you see, this is a way where the real competition in latency happens and between HFT traders. So when they just divide the response time by number of 2, it does not help them and does not help us to explain why the latency for my order was 1 millisecond instead of expected 300 microseconds. But in fact, the jitter on the way to the exchange is much more important than the time it takes to stay in a short queue on the matching engine and so on at high load.
You see, there are several aspects here that blocks this, let's say, this calculation. First is the time synchronization issue. We have to be very, very precise in terms of time on several components of the network infrastructure. The second issue is that usually components of the application can communicate with each other using some kind of internal protocol which we are not able to understand, let's say. So it's not possible for us as a tester. We test in a black box usually, so it's not possible for us as a tester to match our inbound messages with internal messages of components.
Okay, a short remark. I did such estimations on the values of jitter on the way to the engine by a simple measurement. On the real market, I got a dump of incoming messages and calculated the probability that the message that came few microseconds earlier than the next one actually receives the exchange order number higher than the next message. So this eliminates the issue with the time synchronization. You just give a jitter curve or the probability to win or fail for the 2 consecutive messages. Just a hint.
Yeah, I mean, but how you measure the time from point let's say,
at the gateway entry or at the firewall entry, it doesn't matter.
yeah, we were talking about time from this point to this point.
I cannot measure this time for
Yeah.
the time accuracy issues also, but
Yeah.
actually I don't need to know this time in terms of is it 50 microseconds or 60 microseconds. What does matter is the jitter this time.
Thank you.
Just short addition. First of all, yes, of course, the most point for us it's latency on client access firewall. Yeah, but again, everything depends on our customers and what we can do in this system. Latency on communication gateways might be also interesting for us as well, if we can measure there, if we can capture traffic there. Sometimes for some systems, it's also possible to capture traffic between communication gateway and matching engine inside the system. But yeah, there are a lot of problems with this, and developers should be aware of this, and they should provide any information or some information for us to help us to do this, because it's not a common problem here, and this protocol might be closed and we cannot do this. Also, it might affect latency inside the system if the system will write this pickup files, for example, or any traffic, any types of traffic. So it's really depends.
Sorry, I need to clarify. Of course, Millennium system captures all internal latencies that we have within our servers. The only thing is we never trust any system, including the best in-kind systems, to do their own measurements. So of course, we have a very efficient, a very user-friendly front end that shows us stats that is collected and aggregated every second on all internal latency links, including matching engine processing, including connectivity between internal components, but we just don't trust it. Sure, we check it, and we use it to cross-check against the measurements that we do using network dump, but we are not relying on any measurements by any system. So do not trust in anything is the main the motto of latency measurement and of non-functional testing.
Спасибо.
Thank you.
One more question.
Hardware, software specialist. Guys, do you use hardware or software to capture the incoming packets?
Hardware, yes.
Hardware, okay. And do you
And software as well. So in some systems, we use hardware appliance to capture traffic. For our main market and other markets, we rely on hardware appliances. Internally, quite frequently in test environments, we have to use just TCP dump to capture traffic. It is less reliable, but still it's okay for most applications.
do you compare your results with the competitors who provide the same service? For example, Corville.
Yes, we do compare our results with Corville.
Thank you.
Okay.